welcome to week 11 chemistry lab. I'm so happy you're here with me. Before we start this lab, let's recall what we talked about on Tuesday. So on Tuesday in class, we talked about mixtures. We had talked the week before about chemical reactions, and with chemical reactions you mix two things together and they create something completely different on a molecular level. With physical reactions, you can mix two things together, but they don't change on a molecular level. It doesn't create something completely new. So with mixtures, that is when you take two or more things, you put them together, but they don't change. It's a physical reaction. They don't change on a molecular level. So with that being said, we are going to start our experiment with mixtures. So the first thing that we're going to do is we are going to work with milk. We'll have milk, food coloring, and dish soap. So my question for you is, when you have milk, you have food coloring drops that you drop into the milk, and you add dish soap. Do you think anything's going to happen? So go ahead, push pause, come back after you've written down your hypothesis, and we'll get things started. I'll go ahead, I'll put up the supply list, and then we'll come back and start. All right, I'm here. I have the supplies. I have milk, okay? I have dish soap and food coloring. I have a bowl, and I have a cotton ball. So I'm going to add milk to my cup. I'm just going to eyeball it, but it would be about a half a cup of milk. So here's some milk. Not in my cup, in my bowl, obviously. And I'm going to add some drops of food coloring. I'll do it just randomly. They're spreading out a little bit, not much. It could be because I just poured in the milk, so there could be some like residual movement that we can't see. All right, and I'll do some yellow. I'm just having fun with this. I have my cotton ball. I'm going to take a tip of it. I'm going to put it in there. What do you think will happen? So I'm putting it in the milk. Okay, nothing happened. I mean, there's some movement just because it displaces the milk. But now I'm going to put some dish soap on the top of my cotton ball, and I'm going to dip it in. So what do you think will happen? So here we go. Whoa, look at that. Do you see that? It all pushed and moved to the side. I'm going to just have fun and drop a couple drops in. Do you see all of that movement happening from the putting some dish soap in there? Wow, things are mixing. It's a pretty cool mixture, don't you think? All the different colors swirled together. So let's talk about what we just saw. So with milk in class, we learned that it is a mixture. There are two types of mixtures. We have heterogeneous mixtures, and that's where you can see that there's a mixture, sort of like a cookie with chocolate chips, and you see the chocolate chips in it. But then there's the homogeneous mixture, and it's mixed so well that it looks like it's one thing, and that is what milk is like. So with milk, there's fats in there, there's proteins, there's water, there's a lot of different things that make up milk. So when we take a look at milk, let's take a look right here, and we added the food coloring, all that happened was the food coloring initially just sat on top of the milk. It might have moved just a little bit because there's some movement of the milk from me pouring it. I probably should have waited a good minute or two so that there would be no movement, but it pretty much just sat on top of the milk, and nothing was happening. But then when we took the dish soap and we added it, what you noticed was it all just shot back to the sides of the bowl, and there was all this movement. So when we have soap, it is bipolar. It means that one part of it is hydrophobic. It means it fears water, and the other part is hydrophilic, that it loves water. So when it is added to the milk, there's one part that's joining to water, and the other part, the hydrophobic, that's afraid of water, is joining to the fat. So when the soap is added, the soap molecules that are hydrophobic are looking for the fat molecules to join with. And from that, it's creating all this movement as molecules are being pushed and shoved around, creating the different swirls. So with this, we're able to see that milk is a homogeneous mixture. And if there were not fats in the milk or water in the milk, then we would not see that movement created from this soap, which is hydrophobic and hydrophilic. Take a look at the mixture now. It's really cool to see the different patterns that were formed. Now this next, well, it's not really an experiment, it's more of an observation, is going to show more about milk being homogeneous, okay? So I'm going to go ahead and put up the supply list. Go ahead, get your stuff, come back, and we will do this together. All right, I have my supplies. Not much was needed. I have a jar with a lid, and I have heavy whipping cream, okay? So all that we are going to do is we are going to take our jar and we are going to fill our jar, not fill it completely, but we're going to pour some heavy whipping cream into it, like that. All right, and I'm going to go ahead and put the lid on. We're going to let this get to room temperature, and then we will come back and do this together. So let yours get to room temperature, let it sit out for a little while. All right, my whipping cream is at room temperature. We're going to make sure this lid is on really tight, and then we're going to shake it for about 5 minutes. So you shake yours, and I'll shake mine, and we'll come back in 5 minutes. All right, I've been shaking it for 5 minutes. I'm going to show you what it looks like so far. I still need to shake it a little bit more. So if yours looks like mine, keep shaking it. I'll be back in another 5 minutes. Okay, so I was shaking it, and at first it was like, how is any of this really shaking? It felt like it was all stuck to the side of the jar. And then all of a sudden it felt completely different, and I know the change had happened. So I'll show you what mine looks like now. And if you look, you have all this liquid, this watery substance, and then look at that. Okay, so what happened is when we were shaking it, the heavy whipping cream, that's a homogeneous mixture, started to separate. And then so fat globules started finding other fat globules, and then they all came together and separated. So this watery substance is what you would call like whey, and here is the big fat globule that if we add a little salt to it, we would be making homemade butter, which is really neat, huh? So we were able to see that, yes, heavy whipping cream is a homogeneous mixture. We were able to separate that mixture and create some butter whey and some butter. All right, it's time to start the last experiment for this lab. So I'll go ahead and put the supply list up. You can push pause, go get everything, come back, and we'll start this lab together. All right, I have my supplies. We have chalk, I have 4 pieces. I have different markers. I have 4 different markers. You can use more or less. It's up to you. And I have a cup for each piece of chalk. So I have 4 cups. Okay. So with this, I want to ask you, what do you think is going to happen? We are going to be drawing a line around each piece of chalk with a colored marker, and then we are going to place it in water. So what do you think is going to happen? Do you think the line's going to just stay right there? Do you think the whole piece of chalk will turn the color that is marked on it? Go ahead, write down your hypothesis, push pause, and come back, and we'll do this. So all that we are going to do is we are going to go about an inch up, and we're going to draw a nice, well, not nice, mine's not nice. We're going to draw a line all the way around it. Okay, so I have a pretty thick line around the chalk. So you can go ahead, push pause, and do this with each of your pieces of chalk, and then we'll move on to the next step. But just so you can get an idea, there's one line on a piece of chalk. There are all the colors. I have all of them. And now I'm going to take my 4 cups. I'm going to place them in, get an idea. I don't need to get an idea of how much to fill it up with water. I don't need to fill it up much. I'll fill it up just a little bit in each cup. There's one. I'll put the blue in. See, you don't want the water going over touching the line. I'll do that. Okay, I'll do another. That should be good. For the red, I'm going to set it up. I'm going to try my best. I don't want that line being dipped inside the water. Ooh, that one's a little high. I'm going to dump some out. Okay, that should be better. I'll put the purple in. And I'll do green. Okay, I've placed them in the water, and we're going to see what happens. You can be looking at yours and seeing what happens. Let me change this view. If you look, I don't want to move it too much. If you look at the blue, you can see that it is moving up the side of the chalk. Do you see that? It's moving up the side of the chalk. So take about 3 minutes and keep an eye on what's happening with your chalk. Go ahead, push pause, and then come back after 3 minutes and we'll see what happened. So here are the results that I got. As you can see, water moved up the chalk, and so did the colors, but it's not just, like this was the purple on the chalk. It's not just the color purple that we are seeing. So let's talk about what happened. So we may think when we see the color purple that that is all that we are seeing, that there's just purple dye in here, but there are different pigments, different colors, different pigments that make up purple. So if you can think of it, do you remember what 2 colors can you mix together and get purple? So it would be red and blue. So you mix red and blue together and you will get purple. So with the water, the chalk is sitting in the water, and chalk is made out of calcium carbonate, and calcium carbonate is very porous. It means it has lots of holes in it, and it absorbs the water. So the water starts flowing up the chalk, and there's the different pigments that are in purple. Some are bigger, some are smaller, and as the water goes up, the smaller and lighter pigments are going to go up faster with the water, whereas the heavier, bigger molecules from the pigments are going to stay behind. So it creates this spread of colors that we can see. So when you look at the purple that was on the chalk, you can actually see that there is some red and some blue. Do you see that? It has separated Okay, so it's neat to go and look at each of them. This is the green. Yeah, it's hard to see, sorry. Yellow, yellow and blue make green. And so you can see some blue down here. You can see some yellow up here. So it's just really neat to see the different pigments that are added together to make a color. So when you separate mixtures this way and everything divides and separates, this is called chromography. You remember in class we talked about different ways that you can separate mixtures, and we had said evaporation, filtration, sifting, magnetism, and the last one was chromography. So you just did an experiment with chromography. You were able to separate pigments using chromography. Well, I hope you enjoyed all these experiments. We had a lot of fun learning. I will see you later in class. Until then, happy learning. Bye, guys.